Okay, in chapter 11 we are going to talk about two sample tests of the hypothesis. In chapter 10 was one sample, now we have two sample. So we are comparing two population. If you look at the example here, you see that I just read the first example. Is there differences in the mean value of residential real estate sold by male agent and female agent? So you see we have two groups, male and female. So you read the other example, you will see that we have two group, of course, two population. So when we want to compare two population in the condition that we know the population variance, we are using the z-test again. So what we need here, we need the standard deviation, we have mean from the two sample, and of course we need n. So if we have all these, we know the population variance and standard deviation. So it's going to be this formula with the z, of course, distribution. Look at the example here. We have two lane in the one market, supermarket, and they want to know which one is faster. They're comparing them together. So the store manager would like to know if the mean checkout time using the standard checkout method is longer than using the fast lane procedure. So you already know how to write the hypothesis because the keyword here is longer, right? She gathered the following data, and hence the time include both waiting in the line and checkout time. So they give us the data related to the sample mean, population standard deviation already given, and of course sample size. So when we have all this information, we know that what kind of formula we have to use, and we go exactly through the process of hypothesis testing. So the first step is we have to write the hypothesis based on the keyword that they already give it to us. Remember, is longer. So always we said the keyword is going to be in alternative hypothesis, and equality is always is in null hypothesis. You don't forget this one. Always equal is in the null, and whatever we want to test is going to be in alternative hypothesis. So we write the null and alternative hypothesis. Significant level, they will give it to us. So the second step is just to know that how much is the significant level. And based on that, we will decide now which test we have to use. Because we know the population variance and standard deviation, of course we have to use the z-test, and write the decision rule when we are going to reject the null hypothesis and when we are going to accept the null hypothesis. And so you know how we decide, right? There is two criteria to decide. The first one is you have to, based on the significant level, you have to get the value from the table, the z table. And the second one is you have to use the formula to calculate the value. So you have two values now. You have compared them together to see that the value that you get from the formula is in which region? Is in the rejection region. If you look at here, you see this area is rejection region that we already here. They already identify the area, or acceptance region. So based on that, you will decide that now here you see if the value that you get from the formula is greater than the value that you get from the table, you will reject the null hypothesis, right? So the next step is to get the sample, and after that make the decision. So if we get the sample, we calculate the mean for the sample. They already give us the mean and standard deviation for the population. We put everything in the formula. We will reach to the value of 3.123. We already went to the z table and we get the value from the table. So we compare these two together, the value that we got from the table and the value that we calculate based on the formula. The computed value from the formula is 3.12. The value that we get from the table is 2.32. So now we have to decide. We have to reject the null hypothesis, right? Because the value that we got is in the rejection area, is more than the value that we get from the table. So what does it mean? It means that the differences that is between the minutes, the time differences is not happen by accident. Of course, there is a differences between fast lane and standard lane. So what about the time that we don't have anything about the population? We don't have information about the standard deviation. Remember that time in the previous chapter, if we don't have information, we use t-test, right? Here also is exactly the same thing. The only differences here is that because we have two population and two sample, we pull them together to use the t-test here. We will see how to do. So even because we have two sample and two population, even here you see if the t-distribution is used as a test statistic, if one or more of the sample have less than 30 observation. Remember we said less than 30 is t-test, of course, and when we don't have information about the population. So of course we have some assumption that we will follow. So the first step is to pull them together. How to pull them together is we have a formula here. You see this is the formula how to pull them together. So we have a sample size, we have a standard deviation, we put in the formula. After that, when we pull them together, we can use the T formula here to get the value from the formula and compare it with the value that we get from the table. So again, exactly the same procedure will happen. We will compare them together, and after that we will decide that we have to reject or we have to accept, right? Okay. Okay, so here we have an example. We have two samples with different, of course you see one has 5 and the other one has 6, and both of them less than 30. So we know that we have to use t-test, right? So they give us these two, and they ask us, is there any differences between these two sample in terms of is there a differences in the mean time to mount the engine on the frame of the lawn mower? So now what we have to do, we know already is t-test. We have to pull them together first to be able to calculate. So let's see, they already give us a significant level that is 0.1. So we go for the first step. First, we will write the null and alternative hypothesis. They said, what was the keyword? The keyword was, is there any differences or there is no differences? So we know that when they said they didn't give us any direction, they just said, is there any differences or not? It means that equal or not equal. Equality is always in the null hypothesis. Non-equality is in the alternative hypothesis. Significant level, they already give it to us. Which test we have to use? We already learned that since they didn't give us anything related to the population, we have to use t-test. And decision rule, of course, we have to write that we have to compare the value that we get from the table with the value that we will get from the formula. And after that, see if the value is in the rejection area or in the acceptance area. But look at it here, when you want to write the decision rule, we have two samples, right? Remember, we have two samples, and one with the 5 and the other one with the 6. Normally in t-test, when we want to calculate for the table, we minus 1 degree of freedom. But since here we have two samples, we minus 2. Be careful about that. So we add that 2 together, the sample together, and after that minus 2 to get the degree of freedom. And since it's two sides, because the differences is both sides, so we divide the significant level in 2, right? And after that we get the value from the table, that is 1.8 in the positive and negative side. So the next step is we have to calculate the value from the formula and compare them together to see how it is. So the first step is to calculate the mean, calculate the standard deviation based on the formula, pull them together first. After that, when we pull them together, now we can put in the final formula and calculate it, and we reach to 6.2. Now we have to compare it with the value that we get from the wait. So we get the pool here, yes, and after that we put in the final formula, we reach to 0.06. Now we compare with the value that we get from the formula, from the table, formula with the table, and we see that is the value that we get minus 0.6 is in the rejection area or in the acceptance area. We see that is exactly inside the region that is acceptance area. So what we should do, in the end, we said the decision is not to reject the null hypothesis, because the value that we get is exactly inside the acceptance area, not in the rejection area. So what does it mean? The data show no evidence that there is differences in the mean time to mount the engine on the frame between these two companies. I will continue with the next video.